Now, we just practiced graphing the inequalities, but sometimes you're going to see inequalities that don't have the variable all by themselves. You need to solve for it first and then graph it. So when you solve an inequality, it's going to be the same way that we learned how to solve an equation. So whatever you do on one side, you need to do the other. And then there will be a few other rules that we'll talk about later in the notes for these. So in this example, I have 9 is greater than 3x. So I need to get x by itself here before I can graph my inequality. So we have to think about, okay, well, what's happening to our x? In this case, 3 is being multiplied by x, so we do the opposite, which is dividing by 3. And just like in an equation, whatever you do on one side, you need to do the other. So we're going to divide by 3 on both sides. 9 divided by 3 is 3. This inequality sign is going to come down, and then 3x divided by 3 is just going to get us x. So now we have 3 is greater than x that we need to graph on our number line. And in this case, the little side of our inequality sign is touching our variable. So that means we'll be graphing to the L. So if I label my numbers from least to greatest, we're going to be graphing towards the L this time. Now the number that we're talking about is a 3, and we're going to need an open circle on 3 because we don't have an or equal to part of our inequality. And I'm graphing towards my L, which means I'm shading to the left, and I'm going to include the arrow down at the end. So if you check this, if you plugged in, say, -2 for x, you would have 3 is greater than -2, and we know that that's a true statement, so we're good. So it's a good way to check to make sure that you shaded to the correct direction before you move on to your next problem. Now we can go to our next example. We have 1/2 x is greater than or equal to 2. So we look and find our variable, it's on the left side here, and right now it's being multiplied by 1/2. Now remember, whenever you have a coefficient that's a fraction, we just have to multiply by the reciprocal. So we're going to multiply by 2/1 on both sides here. When we do this, this just becomes x is greater than 2 times 2 is 4. 4 divided by 1 would be 4. So that gets us x is greater than or equal to 4. Now this time, our greater side of our inequality is touching our variable, so this is the big side. So that means we're going to be shading towards the bigger numbers, or g. So from least to greatest, we're going to be shading towards the g, the bigger side here. So the number that we're on is 4 this time, and we need a closed circle because we had an or equal to type of inequality symbol. And we're shading towards the g. And if we want to go ahead and check, we could put a 5 in for x here. So if we plug in 5 is greater than or equal to 4, that is true. 5 is greater than 4, so that's a true statement. We're good to go. Now we have some two-step inequalities. At least in this next example here, we have 2x plus 5 is less than or equal to 9. So remember, when you're dealing with a two-step equation, we always looked for the constant first. It's going to mean the same thing here. We need to get rid of the constant from the side with our variable first. So 2x plus 5, the opposite of plus 5 is minus 5. So I do that on both sides of my equation, or my inequality. 2x comes down, and our 5 minus 5 goes away. The inequality symbol comes down, and 9 minus 5 is 4. Now we just have to treat this like a one-step inequality. We have 2x is less than or equal to 4. Right now 2 is being multiplied by x, so we're going to do the opposite and divide by 2 on both sides. When we do that, we're left with x is less than or equal to 2. So now we need to put a closed circle on 2 because we have less than or equal to. I'm going to put my L and my G to decide which way I need to shade. And the little side here is facing our variable, so we'll be shading towards the L this time. I'm just going to fill in that whole side. And then if we go ahead and check any of these numbers, I'm going to use 0 here. 0 less than or equal to 2. Yes, that's true. 0 is less than 2. So this is a true statement, and we shaded correctly. You should go ahead and try number 4 on your own. You can pause the video and then check when you're done. All right, now that you've tried it, you can check your work. We have x plus 7 over here, and to get our variable alone, we need to do the opposite of what's happening. So instead of adding 7, we're going to subtract 7. And remember, whatever you do one side, we got to do on the other. So we have 12 minus 7 is 5. Our less than sign comes down. And this plus 7 minus 7 is going to be gone, so we just have x over here. So I have 5 is less than x. So we have the big side of our inequality sign touching our variable this time. I label my L and my G. I'm going to need an open circle on 5. And since we're touching the big side of our variable here, we need to shade towards the G, the greater number. So we'll be shading to the right. Now if we check to make sure that looks good, a number that would be to the right of 5 would be 6. So if I plug in a 6 where x is, 5 is less than 6, yep, that's true. So we did it correctly.